one last way of solving inequalities. It's called sign analysis, and it starts off with factoring the expression completely. So if we have minus 6x squared minus 39x minus 18, obviously we could take a negative out of each of these, and also each of these numbers is divisible by 3. So we can take a negative 3 out, and that will leave us with 2x squared plus 13x plus 6. So now we need two numbers which add up to 13 and multiply to 2 times 6 is 12. That's easy enough. 2x squared plus 12x plus 1x plus 6. So from the first two of these terms, I'm doing decomposition kind of fast because I don't have a lot of space and we've had a lot of factoring practice. We take 2x out of these first two terms and we're left with x plus 6. We factor 1 out of the second pair and we get x plus 6 again. So there's our factored form. Now, if you're going to do sign analysis, minus 3, you start with your factored form and you do a couple of things with it. First, you have to find all of its zeros, meaning we have to solve when 2x plus 1 equals 0, or when x plus 6 equals 0. We get one solution from each. Either x is minus 1/2, or x is negative 6. So, next thing that happens, we make a chart, fairly big one. Down the left side, you put each of the factors. We have minus 3, we have 2x plus 1, and we have x plus 6. Down this side, we have to put a bunch of ranges that we're going to check. We know that this equation does interesting things at minus 6 and at minus 1/2. So we have marks here for negative 6 and for minus 1/2. And we have to check a whole bunch of different places here. We have to check the value of each of our factors when we're below minus 6, when we're right on minus 6, when we're between negative 6 and negative 1/2. We have to check right on negative 1/2, and we have to check above negative 1/2. That's a lot of calculations, granted, but remember we only have to check the signs of these, not the actual values, so it actually doesn't take all that long. The first one is ridiculously simple. Negative 3 is negative no matter what. It doesn't even care what the value of x is, so that one takes seconds. Now, if x is below negative 6, let's say it's negative 7, here we get 2 times negative 7 is negative 14, plus 1 is negative 13, so it's negative there. At negative 6, 2 times negative 6 is negative 12, plus 1 is negative 11. If we're between negative 6 and negative 1/2, let's say negative 1, 2 times negative 1 is negative 2, plus 1 still comes out negative. If we're right on minus 1/2, then we get 2 times minus 1/2 is minus 1, plus 1 is 0. 0 isn't positive or negative, so you have to mention it specifically. And if you're above minus 1/2, let's say 0, you get 2 times 0 is 0, plus 1 comes out positive. Now we do that again with x plus 6. If this number is lower than minus 6, say minus 8, and then you add 6 to it, it comes out negative. If x is negative 6 and you add 6 to it, then you get 0. If x is between negative 6 and negative 1/2, let's say it's negative 1, negative 1 plus 6 is positive. If x is negative 1/2, you get negative 1/2 plus 6, comes out to 5.5, positive. And if x is above negative 1/2, so let's say it's 0, you get 0 plus 6, and it comes out positive. So there's all of our outcomes in our sign table. or sign chart, sorry. And now we do an overall result for each of these. When we're below -6, then the factors in this thing are negative, and negative, and negative. What do you get when you multiply three negatives together? You get a negative result. What do you get if you multiply a negative and another negative and 0? You get 0. What do you get if you multiply negative by negative, that's positive, by another positive value? Comes out positive. What do you get if you multiply a negative and 0 and a positive? Comes out to 0. And what if you do negative times positive times positive? Comes out negative again. So, it takes a while to build this up, certainly, but now we have a very nice detailed picture of how this curve behaves. We know that it's negative when we're below -6. It hits 0 right at -6. It's positive then until we get to -1/2, where it hits 0 again, and then it goes negative. So we know pretty well everything we could ever want to know about the signs of this curve. And the question they're specifically asking is, when is this curve less than or equal to 0? Well, it's less than 0 out here. It's less than 0 up here. And it's equal to 0 right on those two intercepts. In other words, this and this and this and this are the regions where it's either lower than 0, meaning negative, or it's exactly 0. If you wrote those out, you'd get everything less than or equal to -6, or the parts that are 1/2 or greater, meaning x is greater than or equal to -1/2. So all the negative things satisfy this because they're lower than 0. These 2 points where we're at exactly 0 also satisfy it because it said equal to 0 is okay.